Good morning, good afternoon, good evening. Welcome to a special edition of the Data Services Office Hour. I am Chris Short, executive producer of OpenShift TV. I am here with the one and only Karan Singh. He is going to be demonstrating smart or green cities, however you want to phrase it, call it what you want. It's essentially, we have a lot of it going on here in Detroit. Detroit, Michigan is where I'm from. There's a lot of activity in the autonomous corridor space between downtown Detroit and downtown Ann Arbor, where the University of Michigan is. So this topic is near and dear to my heart. So I will hand it over to Karan to introduce himself. Please take it away, Karan.
Hey, thanks, Chris, and thanks for having me here. Hey, guys, I'm Karan Singh, Senior Architect at Red Hat. And yeah, same as Chris. So a lot going on in my city, Bhopal. From Bhopal right now in India. And we're going to talk about smart city and green city today. And we would be showing you off how you could build a pattern of using open source technologies and adopting that in a use case. And the use case that we have chose for the day is live capturing of images from vehicle and detecting the number plates in real time, and the entire data chain from that point. So that would be pretty interesting. I hope that you guys would find this useful. And the whole idea of this is that this is just a demo of a kind of a fictional scenario that we have built up. And since this is all running on OpenShift, it is leveraging OpenShift as the core engine. And we are using lots of open source technologies on OpenShift and building patterns so that you guys can learn more from these patterns and try to adopt these patterns into your apps, your production apps, your kind of use cases. So that is the whole intention of this mini demo, I would say.
Cool.
So to set things set up here, I'll share the screen and give you a glimpse of what we're going to talk about and where our story going to revolve today. So Chris, just verify if you can see the screen. Okay,
You're
fantastic. I'll promise I'll not bore you guys with lots of screens and presentation screens here. There are so many, so I need to select which one to show off. This one is real quick. You will. By the way, I'll give you the URL of the GitHub repository that we are using to store all the code bases, all the OpenShift YAML files, sample data sets, automation, including the documentation that you guys can see and peek around and the atmosphere. So these kind of things that we can do once we have number plate of the car, right? So this demo goes like this. You have at each tolling station, we will have OpenShift at the edge deployed, and we have I think I'll switch to this one. So yep. So yeah. So we will do inference as the edge. We have OpenShift deployed on the edge, and we have our model, which is trained on detecting cars and extracting out the number plate. And at the same time, it will extract the characters of the car number plate. And once that model has detected a number plate from the car, it will basically send that onto a Kafka topic running on the edge. So right now we are at the edge. So this is all happening on the edge. We need to make sure the data should also come to the core because this is hybrid, right? We need to build an edge kind of a situation and scenario. So the data will go from Kafka topic and using Mirror Maker. This ANQ streams has a nice feature of Mirror Maker. Or Kafka has a nice feature of Mirror Maker, where it can you can move messages from a distinct Kafka cluster onto another Kafka cluster. So your take should be on this is that okay, this is one pattern. You'll see a pattern here. This is a event driven, loosely coupled scenario where you have edge and core, and you want to move data from the edge to the core. So this would be the actual or the main pattern that you would be deploying in your apps, right? Kafka Mirror Maker will make this happen, and messages will move from the edge onto the core, right? And once
Yeah.
you have message on the core, which means the message would be like a JSON string of the car. At this time, we don't know much about this car, right? Because we just have detected the number. Then we will do rest of the processing on the core data center. So in here, we will process it. We will have multiple business logics which will work on that detected number plate. Like, okay, please tell me who is the owner of this car, right? And in real time, we can go and talk to a database running on OpenShift or a MongoDB. We don't have MongoDB here, but yeah, it's just a database that is running, which will give you, okay, this car belongs to, let's say, Chris, and then we will store, okay, this is the car that Chris was driving at this time. We'll put a timestamp on that event, so that event will get enriched with some more data on the core. So we are enriching the data generated on the edge, move to the core, and then this enriched data could then be further utilized. So for example, another would be used to like this. I have another service here, which is alert service, which will say, okay, I was looking for this car. This car was lost or stolen from somewhere. If this number plate matches with the string or on the Kafka topic, we will immediately send out alerts to the relevant organization. The third one would be storing this for a longer term on a low cost object storage solution, so that this could be retrieved and used for data analysis, data dashboarding in real time. So we rely on, and we use S3 as the de facto way to store data on object storage. So we use OpenShift Data Foundation backed by Ceph. So Ceph is the underlying technology that stores this. And once the data is there, you could use tools like Trinio. Trinio is the open source project, and the downstream product is Starburst Presto. I think they changed the name recently, so I cannot recall the name. But yeah, once you have so Presto is pretty interesting tool. This is a distributed SQL engine. So the way it works is that from Trinio interface, I will just I'll say Trinio or Presto, so don't get confused. It's just the same tool, upstream and downstream. So Trinio is the open source version of it. So on Trinio, you will say, okay, you will write SQL statements, and this Trinio engine can in the backend it can run distributed SQL queries that if the data is living on let's say RDBMS or a MongoDB or an S3 object storage system like ODF, from a single interface you could query in standard SQL the data. So this is very powerful, right? You don't need you don't need like 3 types of different tools to pull data out from different database engines and object storage. Trinio can do it for you. Object storage, Ceph is the Ceph is pretty fantastic. It is ST compliant, so there is absolutely no problem for Trinio to go and talk to S3, ODF S3, and push the data out. And once we have data on the once we have the SQL engine ready, we can query it by CLI if you are a fan of it, if you want to do it. But most people prefer to prepend one dashboarding system or a reporting system. It could be Tabulo, or it could be open source, like it could be Apache Superset, to query, do an ad hoc query on Super. Write an ad hoc. I'll show you this thing. This would be pretty interesting. Write a query on Superset. It will go to Presto, and then it will go and fetch data from S3. That is pretty fantastic. We also have one dashboard, like an operations dashboard, so that people can see what's going up. So at this time, this is what we're going to talk about. Again, I would emphasize on the patterns here. There are a lot of patterns which are inbuilt in this demo that we are showing to you, like inferencing at the edge, because this thing is really getting attention. Like, I want to do machine learning and AI inferencing at the edge. Help me do it. So this is the way you can have it. And once you have done the inferencing, you need to move the data to the course for long-term preservance, or it could be like an ML ops scenario where you are continuously getting new images. If the model is not able to detect that image, you wanted to have that image that was not detected and train the model in the backend later, and then push the model back to the edge location. So this all goes in containers, and OpenShift, and for that matter, Kubernetes is we believe is the right way to do edge and core and have these MLOps kind and data engineering thing tied in together. So Chris, does this make sense? Anything that you wanted to ask me at this time, or help me, or should I explain more on any of these sections? Chris, can you hear me?
Sorry, Chris is Chris is having internet problems right now. I'm his intern, so.
Okay, no worries. So I hope this streaming is still going on. I hope so.
Yes.
Okay, fantastic. No worries. So what I'll do next is, meanwhile, Chris is busy fixing his cable internet connection. So I'll take that moment and walk you through. I think I will walk you through my GitHub repository, because that is the core thing that has all the. So So my colleagues Guillaume and Kyle, who are not on this call, I guess they would be listening to this or tuning to this. They help, three of us. We have spent a lot of time on this, and we built this demo. And the way to use this Git repository is that we will have multiple patterns. So this is one of the patterns that we worked on, so called a smart city pattern. So you go into this directory, smart city, and then you will have a full-blown documentation that you could use for deploying each and every component of this demo. So this is a pretty comprehensive documentation that will show you how to deploy this entire smart city, green city project on your OpenShift environments. This could also be deployed on Kubernetes, but yeah, you would need to code that and do some changes at your side, but that should not be too bad to do it. So yeah, this should equally work well on Kubernetes. But yeah, this has been tested multiple times. I guess like several dozens of times on OpenShift. So we are pretty sure that this works seamlessly on OpenShift. We will yeah one so there is a directory called as deploy. So deploy directory has all the YAML files that you would need to deploy each and every component of this demo. And these demo YAML file includes, creating a secret or a config map or a deployment service or route, the standard Kubernetes and OpenShift thing, right? So you will deploy these components in together, and in tandem they will work once you have things up and running. So Chris, are you back or still? I guess he's still.
I am back.
Sitting.
I think. I hope.
Yes, I can see and hear you.
Yeah, Comcast is the best internet provider out there. Let me tell you. It's the second time this week something like this has happened, so I apologize, everybody. Really, I do.
Starlink is a solution, huh?
Yeah, it's about to be. Far enough north I can get it now. But anyways.
Yeah, so yeah, I was just going through this deploy directory, which will have all the YAML files, and then the crux and the core is inside the source. In the source directory, you will see all the entire Python code that we have built up to write those logics and how this will go and connect to a PostgreSQL database. And then how are you going to store data into this? And then, how would you initialize the Kafka listener? And then how would you move data onto Kafka bus, things like that. So these are all like Kafka consumers and producer configuration. So all the code you can find in in this repository. So yeah, feel free to do and try it out. Let me know if you have any issues. Just create new issues on this repo if you're stuck somewhere. Happy to help here. I will go and show you how does this look like once. Even before I go to, I'll show you my my OpenShift deployment. So you can see that. So this is a running environment right now in a namespace called as Smart City, and we have all the components deployed. Database, LPR service, license recognition service, and image server, generator. The generator is like, obviously we don't have real cameras at the moment. So this is the generator, which is just generating randomly images of the cars. And then this generator data is getting fed into the inference engine, which is detecting the car number. And this is the LPR service, license plate recognition service, which is doing the magic. So yeah, everything is deployed at the moment. We have object storage buckets in here. I'll go and see object bucket claims. We have 2 buckets. I'm using 2 buckets to do it. We are using one interesting pattern here, which is very important for the listeners to see. I'll come back here for a minute. Moving data from Kafka onto object storage. Right, so we are using an open source tool called Stacker. So Stacker originally came from Pinterest engineering. It's an open source project. We thought this would be a very good use of this. That's why they built this, moving how to move data for long-term retention onto Kafka topic. Like Kafka is just a buffer, right? It's a temporary buffer, I would say. It's a log, it's a buffer. You'll not store 10 years of data on Kafka. That does not make any sense.
It's a streaming service, or anything like put those messages through that puppy and off it goes.
Yes, right. So and this data is very critical for lots of reasons. So we thought, okay, there has to be a way. And another dimension was that with we thought, okay, why can we move data from Kafka to a SQL database or RDBMS? So when we talked about this and thought detail, like that's not really RDBMS for, right? You'll not dump traditionally you'll not dump lots of data on RDBMS that just archival data, right? You would need a data warehousing solution for such kind of things. If you want to store petabytes of data for long-term retention. So object storage is kind of the natural choice for us because it's really a pattern that dump your. So this would be a data lake. S3 powered by S3 interface. Ceph object storage is a data lake, and what we're doing with Ceph is a nifty tool which will move based on my filters. It will move data from Kafka topic. It's just a listener. It will move data from Kafka topic and dump that into our own format, like ORC or Parquet, different kind of serialization format. It will format that and then dump that as an object into an object storage bucket. And once data is there on object storage bucket, number one, it is readily available for you. It is cheaper because object storage is typically not very expensive, and lots of tools can know how to access object storage these days, right? So this is a pretty good pattern that people are using in production, and that's why we also use this in a real life scenario. Like, how do you use a combination of Kafka and Secure and S3? How can you dump it? Right. So I'll come back to my OpenShift. So this is my OBC object bucket claim buckets, which are created on ODF object storage. So yeah, pretty much it. We have everything here. I'll show you how does the end result look like. So we have built up this dashboard on Superset. I'll explain a little bit. Like, okay, this is a dashboard for reporting, like real-time reporting. Like, okay, you know how much collection. Maybe I should refresh this. It's been half an hour. I've been talking, so this should get us new numbers.
Oh,
okay,
wow.
Yes.
Busy day in London.
So it's a busy day in London. Look at this. 10,000 vehicles, almost 10,000 vehicles that have been passed from these stations, and out of which we have collected 43,000 whatever pounds of toll fees. It's all make up numbers, but anyways, you get an idea. And look at this one, this pollution fee. So vehicles which are very old, which are emitting lots of carbon into the environment, we are charging them extra. So this kind of a nice dashboard. And then we can see we have, like, as I told you, we have like multiple stations, so we can sort that by station ID. We have built up these panels in Superset. You can also do that. It's pretty amazing and simple to do it. So for example, okay, so station number 5201 is witnessing 22% of the total traffic. So these kind of metrics, you could get in real time using this kind of a pattern-based solution, right? Which means you need to do maybe, I don't know, whatever. You need to put more police or traffic police in this area because
change the timing on the lights, that kind of thing. Yeah, all 9 yards.
Yeah. Right. These kind of things that we should that one can do. And like, who are the top 20 customers? So Mr. Gemma North, he is he has to pay like 4,315 pounds this month. So his monthly bill would be this much. At the same time, you can see, okay, what he's driving. He's driving. This is the address. I mean, this is all fake numbers and fake addresses. So
thank you. I wasn't going to ask on air, but I was really hopeful that was fake data, and it looked faked based off the license plate. So I was somewhat comfortable with it.
Yes. Yeah. So this is all open source license plate car images that we have chosen because obviously we don't have this much of big of a data set, and we can't go and install real cameras. They'll not allow us to do it.
Not for your demo, at least.
Yes, unless you're doing a POC for them. So if anyone from London Smart City or any city, if you're listening to this, contact me. I can help you build this dashboard for real in your state, whatever. So yeah, and this is the pollution fee. Look at this one. Okay, scrolling issues. Going back. Okay, one more time. Come down. Okay, so Susan King, this is a license plate number, and he's driving like a vehicle which is of 2009, which means his engine is emitting lots of carbon. So he has to pay some extra pollution fee of 2,800 pounds. So you got this idea, right? And this is kind of a distribution of, okay, what type of vehicle is more like Audi R8 as for the data set that we're using. and Toyota Land Cruiser are the most popular one, which is going through, and BMW 6 Series, just 2.8%
Fraction.
of the population is doing. Yeah, so
Yeah.
it's just to show you, these kind of things you can do once you have enough data, right data captured from the places, and using these patterns, you should build up this kind of solution. So this is just an example of smart city. You could port this up into an industrial environment, like you're a manufacturing hub, you're a car manufacturing thing. You can do in this kind of situation, use case driven patterns, using open source technologies on OpenShift pretty neatly. So this was Superset. Next, I'm going to show you another cool demo, a dashboard, which is actually showing you live.
Ooh.
This should be, let me see, last 3 hours. Okay, my instance was down. That is the reason it does not have much data.
Right.
So
You said your instance was only 3 hours old, so yeah.
Yeah, I was on a cost saving mode, so I powered off all my. So again, so this demo, this was working fantastic fine. So I powered off all my instances because obviously it's a cost.
Right.
I powered off everything.
And because you can.
Just before I can, yeah. Look at this one. This is all persistent. This is the power of OpenShift. This morning, I just powered on my OpenShift environment just once, and OpenShift brought up all the components, all the services, including my data, everything, without a glitch. So another, I was happy, right? So what you're seeing here is this is that the same London zone, and these are all the places where we have cameras installed.
Mhm.
And vehicles are coming and from these stations, and this is the last detected vehicle number, and this is a real image from the vehicle, and we are detecting in real time the number plate of that car. You see this changes, and you will also notice that this is not accurate because this model is not accurate, right? Look at this one. It's not very accurate, but so this happens in production. You
Yeah.
would not you'd not build a model which would be accurate on day one. This is a continuous learning process, right? You will get new data sets. You have to train it. You have to build an MLOps pipeline so that you can train. And once you have the trained model, you need to deploy it back or ship it back to the edge location so that your edge inferencing engine should get updated with a new model. So you need these kind of tooling at your disposal, so that you can do all these things, without a complexity of things going down or whatever, right? So that's the beauty of OpenShift, that gives us all the tools to do this magically.
Beautiful.
And
I think what's amazing is just the fact that you have it set up so the data just starts flowing in whenever you start your services, and everything just kind of picks up and goes. Like, that is very handy, right? If I'm a researcher and somebody's like, oh, yeah, go train this model, I need to be able to have that infrastructure and the same services and the same data and the same everything available to me. And you can do that with this, right? Like, spin up your own cluster, you'll have everything, you'll see the models with all the unknown description data, and you can clean that up as someone that's just like tasked with cleaning up the data, or somebody that's like tasked with, well, why is there an increase in traffic in this area this time of year, time of day, whatever, and you can go and investigate that with actual real life solutions, right? Like, you can drill down into the data in real time and find whatever it is you might be looking for. And it could be increased foot traffic. It could be anything from, a car broke down in the center lane kind of thing. That happens, right? Like, everything happens in, humans, machinery, cities, like total wild card, right? You never know what's going to happen. There's just too many moving pieces, literally.
Literally, correct. Yes. Yeah. And yeah, that's right, Chris. And and I mean, the thing that fascinates me here is that because edge is really, people are actually deploying these kind of things at the edge, and edge is getting popularity. People across the industry, like financial or let's say industry or automobile, right, or e-commerce or let's say retail, all the industry vertical need they have some or different form of edge, and they want to deploy technology at the edge, right? So and you need tools so that you can seamlessly ship your app, your code basically at the edge, so that you can get these kind of insights from data and collecting it. So yeah, focus on the right tooling, and using the right tool for your job is kind of very important. Yeah. So
Awesome.
so yeah, this is kind of just to show you this is kind of a graph that will vehicles per second, how it is going as per the time. So kind of a heat map, kind of a chart here. Another cool graph and chart here is I should shout out to my colleague Guillaume and Kyle, who were hacking around their skills of using GIF. And I was watching them, what the hell these guys are doing. But then they came up with this.
Okay.
So this is the kind of GIF that they built up, and these numbers are real numbers. So this is the actual, and this is an operations dashboard, right? So
right.
in real time, you are monitoring what service is using how much CPU. So look at this one.
Wow.
My Kafka at the edge is just using 0.5. Oh yeah, it's a 0.05. Sorry, 0.05 CPU.
That's a minuscule amount of processing data. We could put sensors everywhere, I guess, right? Like, I mean,
yes.
Seriously, that is not a full CPU of usage right there.
That's right. That's why so OpenShift on Raspberry Pi should be soon. But yeah, that idea has legs, right?
Yeah, I mean, we're working on single node instances for this reason.
Yeah, that's right.
This is part and parcel why we're working on single node instances for OpenShift, and as time goes on, we'll get better with them. But right now, you could probably deploy this in a very small package, and have everything you need right there at the edge.
Yes, and look at this one. This Smart City Inference API. So this is the API where we have our model deployed. So in real time, this is in a camera or a simulation of a camera. This is sending an image to my Inference API. Look at this red dot, and then data is going back, to my Kafka, and then from Kafka we are using Mirror Maker to send the data to my core. Once the data is on the core, that number plate, it is going to Secker, and Secker is storing that to my Ceph. The remainder part, you don't have arrows and dots here. And then you have superset, which will go and query PostgreSQL database and Ceph object storage, ODF object storage, to build that nice dashboard. So this is the whole journey from the detection until you see a report. And this is all happening using open source tools and on OpenShift.
That's awesome.
Another variant of this is we said, okay, CPU is good. Let's build. Let's just for fun. Let's build memory. So I'll show you that as well. It's kind of the same. This numbers are different. That's it. So this is my memory consumption. Look at this Mirror Maker. 260 megabytes of memory it's consuming just to move messages from edge to core. It is good, right? So yeah, this is my dashboard. I'll come back to I'll also have one other interesting tool that we have used, open source again. CalfDrop. So
I like to learn new tools.
Yeah, I mean, when we were deploying this, we were always going to the CLI, connecting to the Kafka topic and running commands. We love that, but once you are in hurry, you want, okay, I need just one thing that will give me everything, because I need to focus on writing code, right? So this is CalfDrop. You can get it from GitHub, and this in real time, this will show you the messages coming on your topic. So I'm connected to my core Kafka topic. This is the URL from OpenShift, and this is my LPR is my topic, and you can see this is my event, which is detected from the edge. So look at this one, timestamp and vehicle number plate and detections were successful. And this has been detected on station A13. So we are getting this data from the edge, and now the data is in Kafka. We can do whatever we want to do. So this is a little pattern here that you can use. So yeah, event-driven systems using Kafka, they're pretty cool and they are flexible, so flexible. Another thing that I will show you, which is very interesting, is the capability of Trinio, which is Starburst Presto, to write queries in SQL such that it can go and talk to two different destinations where data is stored. Remember in this slide, I talked about that you have data stored on your RDBMS database, and you have data even stored on S3, ODF S3. So, okay, my CPU it's really hard right now, 70%. Something is eating up my CPU. Anyways, so yeah, this part. So Presto can go and talk to database using distributed queries and ODI. So I'm going to show you one, like how does that look like. So this is a simple query. This is a simple distributed query that I'm going to run. That okay, please go and give me timestamp, license plates of vehicle, model number, and owner. And this is written in such a way that it will go and pick up data from my Hive. Hive is a component it's a big data component that it's a meta store which will have information about the tables and the partition definition that where the actual data of this table is stored on which S3 bucket. So it's a big data construct. So like it's a tool. So using this Hive meta store, it will go and query my ODF, which is OpenShift Data Foundation, which is kind of S3 component that we're using here. This query will go and talk to and do a left join on the database, which is Postgres. So again, just take a moment, understand this. From a single SQL query, I'm investigating, or I'm just looking for records which are stored on two different places and getting them on one query. This is very powerful because in real world, I'm very sure you will have multiple different data destinations. It could be PostgreSQL, it could be MongoDB, it could be object storage, or it could be, I don't know, whatever. You might have a third form as well. So you need a single mechanism, and SQL is like, SQL is there since last 40 years. So people know how to write SQLs. So I'm gonna run this. This will take a few seconds. So running the statement, and boom, you have the data here. So this is a real time. We are querying this in real time and getting data from this. If you want to look into how Presto have done this, so there is another dashboard for Presto, and I will unfilter the finished one. So this one is just like just few seconds before, so 7:09 my time. So this is a finished query. This is the query.
Just
and
happened.
I'll go to this. Just happened because we ran it from Superset. Superset will give instructions to Trinio, and Trinio will give instruction or basically go and crawl or get data from RDBMS. So this is Presto, and we can see like plan. So so this is for you, how Presto, because Presto is an engine. It's an engine to write big data queries. So it has its own mechanism of building plans and finding the most optimal plan to grab the data and things like that. So
Wow.
This is Presto. So yeah, this is it mostly. I'll come back to the story where we have started. So again, you can say, okay, Karan, this is not something that you have deployed in a real world, and or maybe to a customer. So how this is relevant to you? The takeaway for all the listeners or watchers on this live stream is that we want you to think how you can use these patterns in your use case, in
Right.
your apps, right?
I mean,
So
this
that
is
is
a
the most important
powerful pattern, right? Like this is a model of models, for lack of a better term, right? Like,
yeah,
I see this and like that video stream, it could be anything coming in, right? Like it could be, test results in a hospital. It could be, at a vaccination site, right? Like talking about,
yes.
what inventories come in and out and, how many people you vaccinated,
Mm.
the whole 9 yards, right? Like there's a lot of applications for this. I mean, factory working, the whole 9 yards, right? Like
True, yeah.
it can apply to cities, but I mean, if you look at a city, there's all kinds of microcosms within that city that this could apply to,
Yep. Exactly. Yeah, that is I mean, because Chris, when we go in and talk to developers and data scientists and people and customers, like, okay, we really like Kafka and we have this AMQ stream, but what should I do with this? You can do this with this, right?
Yeah.
That is the whole idea.
I remember learning Kafka messaging queues, way back in the, whenever they came out kind of days, there were 200 some number after it that year. And like just envisioning the possibilities, right? Like, oh, I could actually like just throw it on a bus and have something else pick it up. That's amazing. And to be able to just like, hey, we're going to have this small deployment out there collecting data wherever it may be, whatever kind of data, it's going to have Kafka running on it, streaming the data back into the core so that we can analyze it and process it better, right? Like there's so many possibilities with that. And then you put OpenShift with Kafka, it's like, okay, what can't you do? That's almost the feeling I have, right? Like what isn't possible? Well, let's figure out how to make it possible. That's kind of what this demo is. And it's really, really cool, right? Like this is awesome stuff.
Yeah, I mean, I'm very excited working on this project because this is just a small thing that we have built up, but we can always plug in serverless, OpenShift serverless here. Like, okay, all of these in real time we are calculating fee, like because it's the calculation, right? So you can have a serverless because late in the night there will be less traffic flowing around, right? So you can just bring down those containers and have instantly wake up once you have a new message in Kafka topic. So that's another pattern, a serverless pattern that you can use. We don't have it here, but that's another pattern that you could pick up to reduce cost. One interesting dialogue that we have been doing with other people within the SA team is okay, persistence. How can I persist data? So in here we are actually using two forms of let me see, two forms. I guess two forms of data persistence using block storage and object storage. And typically, developers, you need to have some kind of persistence layer in your OpenShift environment, and without a doubt, OpenShift Data Foundation is the ultimate choice because I love the technology it is built upon. It is Ceph. It's a 10-year-old technology, and it just works super fine. And we are because this PostgreSQL database, it's a database, right? Database needs storage.
Yeah.
Right. What will happen?
Persistence matters.
Persistence matters a lot, right? Yeah. So like I powered up my entire OpenShift and brought, but if there's no persistence here, I would have been, figuring out how to recover my data, whatever. So yeah, we've been using block storage from PVCs, persistent volume claims from OpenShift Data Foundation, and then buckets. And this is very, very interesting, Chris. I'm pretty sure this has been discussed previously on your channel, but through OpenShift console, you can request for object buckets. Like as a developer, you can request for object bucket, and you will get a bucket and you will get credentials to your bucket. So that's what we are doing here. So we have created two buckets. The first bucket is the dataset bucket where we are storing all the dataset, and the second bucket that we have is for Secker. So Secker is dumping data onto this bucket. So again, this is also a powerful construct. As a developer, you don't care. You just need to write, code in which you will pack S3 Boto, right? And you will say, hey, please give me one bucket or whatever. And this OpenShift using object bucket claim, which is a native, construct in OpenShift, it will provision an object bucket claim on OpenShift Data Foundation and give you a bucket, and then just use that bucket. It's your persistent storage for everything.
I mean, Open Data Foundations is an amazing kind of platform of tools, right? And if you're looking for the fast, easy way, right now we have in tech preview. It's in tech preview, so keep that in mind when you're using this. You can use what's called an assisted installer. Basically, it gives you an ISO, but this ISO can be configured with ODF and virtualization and everything. And all you have to do is just give it hardware and spin up the ISO, and it'll install a full cluster with all the bells and whistles as far as everything needed for this demo, other than some bits and pieces here and there. And the data itself.
Oh,
yeah, did you know it could do that? The assistant installer is pretty cool. I was just poking around in it yesterday, building.
Good to know this.
Yeah, I was rebuilding my cluster, as I do because I break it all the time. This channel helps with that. And I saw it and I was like, well, let me try this. And it was like, there was ODF, there was virtualization, there was everything. I was like, dang, this is really powerful. So it's in tech preview. Check it out. Go to cloud.redhat.com and or try.redhat.com or openshift.com/try. I dropped the link in chat. Stream try. You can hit that. And you can go and look for assisted installer, and you can check a couple boxes, get an ISO, and you'll be up and running in less than an hour, basically. It just depends on how fast your infrastructure is.
Yeah, I'm going to do that, Chris.
Yeah, it's
today.
It was really, really click, download. Okay, here's some VMs on a virtualization, instance.
OpenShift is really moving so fast. It's very hard.
It really does. It moves faster than I think people realize. And our What's New briefings are just, rich with content. If you
exactly. I mean, look at me. I mean, I've been using OpenShift almost daily. I'll daily use OpenShift, but even I don't know about this new thing. Yeah. OpenShift is really running.
Yeah, it's moving at a pace it's hard to keep up with, even from my perspective, having people come on every day to show me new things.
Definitely. And talking about new things, I also have one more cool collection of things to show to the audience here. You see these three things: Superset and Grafana and Starburst. This comes in ODH. So ODH is another open source product, Open Data Hub, which is a collection of tools that help you do data engineering or analytics, things like that, machine learning, all running on top of OpenShift. So it is very flexible and helps you. You can paste these things very easily using OpenShift operator. I'll just really quickly show you. So I've already have it installed, and it is highly configurable. There are so many components to this operator. Okay, I'll go to my install operators. I have it installed. So Open Data Hub is the operator that I've installed in here. And if you go to Open Data Hub and then the KF def, I'll always use this one. So here you can define which all component you would need. You might not need all the components that ship with Open Data Hub, right? You can choose what all components do you need in this YAML file. So I'll say, okay, I need Superset, and I need Grafana, and I also need and this is the magic thing here, Chris. I want to use Trino, which is my SQL engine, and this is how simple it is to use object storage with Trino. okay, Trinio, please go to this endpoint and this would and get your secrets and credentials from these two secrets. And this is the bucket name. This is a storage class. So look at this one. This is how simple it is to configure Trinio to use S3 object storage on
There it is.
on
Yeah.
ODF, right? And once you have it, you will Trinio install the Open Data Hub installer will deploy relevant components in your namespace. Or yeah, once you have this KFDEF applied, it will deploy everything for you, and then it will also give you kind of a nice its own dashboard from where you can just jump onto the right. So ODH dashboard. ODH again is Open Data Hub. It's an open source project, and we have a downstream project called as OpenShift Data Science, which is kind of a collection of more matured tools in here. So right now I'm just using two components from Open Data Hub. You can just go to this and see what all things it does. But yeah, this is Superset and this is Grafana, and there are so many tiles in here. Just choose what components you want to deploy on OpenShift. It's simple.
That's beautiful.
Right. So these toolings will help you build the right foundation for your ML ops journey, for your data engineering journey. You need to have the right tools, and that's what we do at Red Hat. We provide the right tools to all the developers and all the people so that they can build, they can build amazing things like what I've done here.
Come on, there we go. Right.
Yeah, I mean, my CPU is like super hot to.
Yeah, I was about to say you're rendering some stuff.
Look at this
and
one.
Zoom is taking up a lot, and then your browser, and then yeah. Actually, what app is that? I kind of need that.
Oh, this one? Oh, this is Stats. It's again open source.
Oh, really? Okay.
Yeah. I mean, I love open source, so the name of this app is Stats. Okay, this is not coming up yet. Look at this one. Stats. Pretty nice.
Stats. All right, I'll check. I'll dig it up right now.
All right. So,
awesome.
So again, yeah. So guys, here is the entire code base. I invite you to try this out on your OpenShift environments. If you're running this on Kubernetes, you need to do some work and change the YAMLs. The code base should work. The Python file should just work fine. You just need to adjust the you need to deploy root-ceph on Kubernetes, because root-ceph provide you block storage and object storage, and then you need to basically modify some YAMLs. But I'm pretty sure that this will also work on Kubernetes. You need to just do some changes. But yeah, hit up this URL, and there is a nice documentation here, which we are also in process to streamline. This already streamlined, but this is more more kind of a comprehensive, so that we intentionally wanted to be comprehensive, so that you can learn how we are building. It's not like it's not a secret sauce, like
right,
or a black box, right? We want you to work on this, follow this, and I'm pretty sure by the end of this deployment, you would get to know a lot of patterns that you can use in your apps, and make us so proud.
That's awesome. Thank you so much for this demo, and I apologize for my technical difficulties. I feel like I missed a little bit, and
you can always go and watch recording, Chris.
Yeah, that's true. I will, and definitely we'll check out this repo more. I shared it out for everybody to see there.
Yeah.
So yeah, this was an awesome demo, and a mind-opening kind of thing for me. I hope that the audience has had a similar experience despite the technical difficulties. But I mean, this is amazing, Karan. This is awesome.
Yeah. So yeah, I would look forward to I would look forward like how you can pick up these patterns and build your own apps. So again, this is just a demo to showcase you the power of OpenShift and all other open source components that we have used in here, and how we have deployed this. And initially we thought, okay, no, we will have just a single OpenShift cluster at the core. Boom, we are done. Demo is completed. But that was not very realistic, and we want to have something that people can relate, because Edge is really the heat up topic right now. People want to do it, and they want to know how they can do it. Like Chris, we were discussing a few minutes back, like, okay, this is not taking lots of CPU and memory, and this is a misconception that people have. Oh, edge, which means I need to have lots of computing power at the edge. No, you don't.
No,
No, you
it's
don't.
a
Right?
sliver, right? Yeah.
Yeah. Yes.
That's really powerful. So if folks have questions or, want to get in touch with you specifically, is there any way they can do that? Do you have like a Twitter or anything?
Yeah, I have Twitter. I'm active on LinkedIn as well. Yeah. My Twitter ID is, I'll put it here. Karan.
I know. I think I follow you on Twitter. There we go. Yeah.
Okay. And in case I'll also do my LinkedIn, because LinkedIn is something that I almost hate. Like I'm okay. But I need to put it. Find my window. Where's my LinkedIn? Hold on.
You can do it. I believe in you. It's okay.
So LinkedIn demo is filling now. I got it now. Okay. So yeah, I'll look forward if you guys have anything for me. If you want to learn more or need any kind of help on this, so reach out to me and let us know. Let us know in the comment section of whatever platform you're visiting. Like if you have any question, or maybe there could be another interesting thing or a pattern that we would be missing here. You are developers, right? We are all developers, so we can see things from a different point of view. So you might be having something interesting that I would learn from you,
right?
And maybe incorporate that in my next demo, because that's what we're gonna do. We want to build more demos, more use cases that should stay in your mind, and then you can use these things while building your next great app.
Oh, it's all about continuous learning, and right, like think like. Just because you can't use this right now doesn't mean that this demo didn't help. If it says in your brain, you pull it out later down the line, it might, save you a ton of time. You might not need this whole thing right now, but it's all there waiting for you to use, kind of deal, right? And you know where to go get it. And great, again, a great demo, fantastic demo, Karan. Thank you so much for coming on. Thank you, audience, for watching. Coming up later today, we have Dev Nation, the show, with my friend Sebastian Blanc. And then after that, we will be having, well, not immediately after, then later this afternoon on the show, on the channel, we have GitOps Guide to the Galaxy. We'll be talking about Helm GitOps workflows. So please stick around.
Yeah, I signed up for that.
You did? Yeah, cool. All right, awesome. So yes, when in doubt, check out the calendar. It'll link off to wherever you need to go to watch the content, and we'll see you next time. And thank you again, Karan. And this was great. I look forward to seeing more later.
All right. Thank you, Chris. And thank you, people.